Hi everybody, and thanks for tuning in, and thanks for those that are subscribing and those that are viewing my tutorials. And I especially like the comments that I'm getting from everybody all over the world, which is fantastic. Thank you for making me a part of your living room. Today we're going to be looking at a stem and leaf plot. So a stem and leaf plot is a form of what we call quantitative data, represented in a graphical format, and it's used for assisting us with visualizing shapes of various distributions. So for example, what I've got here is a series of numbers. If you want to call them, you can call them years, like ages, the age of individuals, and I've just nominated 18 years, 31, 26, 18, 25, 10, 33, 27, 22, 59 and 39 years. And you will notice that they are not in an order, and I've deliberately done it like that because as an example, in a NAPLAN exam, that's pretty much how you'll get it written up on a question. And what I have done is put it through in what we call a stem and leaf scenario. So stem virtually means grouping the values, and the leaf virtually means the individual numbers that correspond to the actual group. Okay, that's pretty much what the difference between stem and leaf is. And what I'll do firstly is I've put them in groups of 1, 2, 3, 4 and 5. That's simply because we've got 18, we've got a 26, we've got a 33, we've got we don't have a 40, so we don't have a 4, that I still put that in there, and 50, we've got a 50. Okay, so what I've done is I then go through and plot these values here from the start. So this would be 1, so group 10. And the way we read this is we've got this key element here, which is really, really important, guys. That the way in which we read this is if you think of the stem value, in this instance is 1, and then the leaf value, which is 0, for example, 1 and a 0, that's the same as saying 10 years. That's how we read it. And for example, the 1 and the 8, that's 18 years. The 2 and the 2, that's 22 years. That's how we read it. And likewise, the 5 and the 9, that's 59 years. But you'll notice in the group of 4s or 40s, there is no individual years that are nominated in this graphical data. So that would not represent anything there, okay? So the way in which we go through it is we go through each and every one. So we've got a 10. So there's my 10. There's my 10. We've got an 18. There's my 18. There's my 18. We've got another 18. There's the other 18. Here we've got 22. If we have a look, there's 22. Here we've got 25. There's 25. Here we've got 26. There is 26, and here we have 27, and there is 27. Here we have 31 and 31, and there is 31. Here we have 33, and there is 33. Here we have 39, and there's 39. Here we don't have any groups in the 40, as I said before. So we don't have anything in 40, which is okay. We just disregard this grouping here. And of course 59, and there's 59. And what's really, really important is we make sure that's why I put a little line underneath, just to make sure that we've covered every single one. And what we actually have is we've got, if you imagine individuals, these are their ages. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 individuals. Okay, individuals. That's really important. We have a total of 11. Now, what we actually want to do is we want to find, we've got a series of questions. We want to find the range. We want to find the mode. We want to find the median, and we also want to find the outlier. So in terms of range is quite simple because it means I just think of the highest value in the data, take away the lowest. So in this instance, the highest value is 59. So it's going to be, so it's equal to 59 take away the lowest value, which is this one here, which is 10. And that's equal to 49. Okay, these are typical NAPLAN questions that you would be asked, typical Year 9 NAPLAN questions, and typical of questions that you would do in Year 10 mathematics as well. Now, when we're talking about mode, we're talking about the most popular number or the most common number, if you want to think of it like that. So I think of, if you want to say most popular, or most common. Okay. Now in this instance here, we can see we've got an 8 and an 8. So we've got an 18 and we've got another 18, which corresponds there and there. So we can say the most common number here, or finding the mode, we can say is 18. Okay. Now finding the median is like finding the middle number. Median is just the middle number. Middle number. Now, there are two ways, there's a couple of different ways in which we can find the middle number. Now, using this stem and leaf plot here, we can say that we've got one number, two numbers, three numbers, four numbers, 5, 6, 7, 8, 9, 10, and 11. So we've got a total of 11 numbers, or 11 individuals. So if you think of it like this, if I think of the number 11 and I think of splitting it in two, I can put 5 on this side, I can put 5 on the other side. That gives me a total of 10. So the middle number will be so the fifth number, the fifth number and the sixth number is, sorry, in this instance here, my apologies. Here we've got 11. So in this instance, sorry, we've got 11 numbers. So the fifth, 5 numbers on the left-hand side, 5 numbers on the right-hand side. So for example, here we've got 1, 2, 3, 4, 5. That's the fifth number. But if we go backwards here, 1, 2, 3, 4, 5, that's the fifth. So there, that's the fifth number on the right-hand side. This is the fifth number. These are the 5 numbers on the left-hand side, which gives us this value here as the center. So I just want to go over that one again. So let's say, for example, in this instance, we've got a total of 11 individuals. If you think of the number 10, for example, that means we have 5 on the left side and 5 on the right side. But we have 11 numbers. So this is the first 5 numbers is on the left-hand side. The second 5 numbers is on the right-hand side, and we want the middle number, which in this instance will be the 6th number, if you want to think of it like that. So what I'd say is that's 1, 2, 3, 4, 5. So that's the 5th number on the left-hand side. Then I start from the bottom and say 1, 2, 3, 4, 5. That's the 5 numbers on the right-hand side, which leaves us with the value in there, and that is actually 26. 26 is the middle number, or sorry, the median. Now, what I was saying before, sorry, when I apologize before, was that, let's say, for example, we didn't have this value here. So let's say, for example, we only had 10 individuals. So let's forget this bottom number here. So if we've got 10 individuals, that means if I split 10 in 2, I have 5 and I have 5. And we actually don't have a middle number. We have to create that middle number. Okay, so the way in which we would create that middle number is that we've got 1, 2, 3, 4. I'll just take this out for the moment. I'll just take that out. We've got 1, 2, 3, 4, 5. That's the 5th number. And we've got 1, 2, 3, 4, 5. That's the other 5th number. So the middle is between these two. So the middle is actually between 5 and 6. So what we would actually say there is if we didn't have this last value and we only have 10, only if we didn't have this last value, then we would say the middle number would be 5 plus 6 divided by 2, which is equal to 11 divided by 2, which is equal to 5 point. Oh, sorry. Oh, my apologies. Okay, very sorry. It should be 25, 25 plus 26, divided by 2. So 25 plus 26 is 51. 51 divided by 2, which is equal to 25.5. That would be the median if we didn't have this number here. Okay? I just wanted to show you that way. The other thing I wanted to just show you as well is in terms of this, let's say you were unsure on how to get the middle number in this scenario, or to find the median in this scenario, you could put these values, this quantitative data, in order of lowest to highest. So let's say we start off with a 10, then 18, 18 again, 22, 25, 26, 27, 31, 33, 39, and 59. Now, the other way in which we could do this, if you were ever in an exam and you were uncertain, this is how we would do it. This is in its order from lowest to highest. So we would cross off the first one, then we'd cross off the last one. We'd cross off the second one, then we'd cross off this one. We'd cross off this one, and we cross off this one. We cross this one, and we cross this one. We cross this one, and we cross this one, and it leaves us with 26. That's another way of working it out, and that's the value that we have there. Okay, it's just another way of finding it out. Now, the other thing I wanted to also say is how we find if we've got an outlier. Now, when we're talking about an outlier, we're talking about a value or a group of values, or it could be a cluster of values that do not fit the data. You can have a look, you can see all these values are very, very closely linked into this group, but if you notice, this one value here is actually very distant from the remaining part of the group, and that would be the outlier, which would be 59. Okay, guys, that's a tutorial on stem and leaf plot, and as I say, this would be a typical Year 9 NAPLAN question. It's also a question that you probably do in Year 10, but it gives you a bit of an insight into how we use the quantitative data into a graphical representation. Okay, guys, thanks for your subscribing and your views, and look forward to further comments. And if there's anything further you want me to show on as a tutorial, please let me know. Thanks, guys. Bye.